Welcome back and thank you for joining me. So yesterday we talked about the very fundamentals of these exponential growth and decay models. Today we're going to continue talking about the graphs of these, but we're going to focus on transforming the graphs, okay? Graphing the transformations. Now I know that you saw stretches in your practice work yesterday, but I want to take a moment still to go over to make sure that you've discovered everything that I wanted you to. So, stretches, recall, whenever you have a stretch or compression or an x-axis reflection, we're going to incorporate that straight into the table. So I'm just going to put that whole thing in my calculator and just start putting in x's. So here, on the calculator, I'm going to do 3 times 2 to the, 3 times 2 to the negative 2 power. What does that give me? It gives me 0.75. What about the negative first power? 3 times 2 to the negative first power gives me 1.5. What about to the 0 power? 3 times 2 to the 0 power gives me 3. The first power gives me 6. And the second power gives me 12. So when you have a stretch, don't forget, just incorporate that into the table, okay? So when you're graphing these, the first thing I want you to do is put in the asymptote, all right? So my asymptote is going to be at 0. So negative 2.75 is going to be about there. Negative 1, 1.5. 0, 3, 1, 6. And then 212 is off up there somewhere. So we draw a line, and then of course it just approaches that asymptote forever without actually crossing the asymptote. So there's my graph. Y-intercept. That y-intercept is sitting at 0, 3. Okay, it's where the x is 0. And notice graphically it's sitting at 3 as well. The asymptote is still sitting at 0. Domain is going to be all real numbers. And the range, remember, you're comparing to the asymptote. Where is my graph compared to the asymptote? The graph is above it. So all of my y values will be greater than or equal to that 0. All right, so what's changed from the parent function? Well, what's changed is adding in that stretch. That stretch, or as they call it, A, it changed the y-intercept. Now, you saw this in the notes yesterday. Remember that last page of notes where we were discussing how to do these things non-graphically? And when there was that multiplier out front, it changed the y-intercept. Now you're going to see that in a graphical sense, that the same thing happens in the graph. When you have something multiplying out front, it's going to change your y-intercept. Okay? Notice the asymptote did not change. Okay, stretches do not change your asymptote. Okay, only one thing actually ever will, and we're going to get to that in a few moments here. Reflections and compressions. Okay, so here once again, stretches, compressions, reflections, they all end up in the table. So we're going to take this whole thing and just plop it right into the table for ourselves. Okay, so I'm going to plug in an x of -2 into the function. So we have -0.53 oh, times 3 to the -2 about -0.06. What about with a -1? So let's plug in an x of -1. We get about -1.67. What about when we plug in a 0? So -0.5 times 3 to the 0, -0.5. Okay, what about 1? -0.5 times 3 to the 1 is -1.5. Let's try 2. So -0.5, oops, -0.5 times 3 to the second power. That's going to give us -0.45. Okay, so again, stretches, compressions, reflections. You just use the whole function. Okay, so here, this is what I'm going to graph now. So you always want to start with your asymptote. So here, our asymptote is sitting at 1 or at 0. And now let's plot some of those points. So we have 2 times -4.5. We have 1 and -1.5, 0.5, then I think I actually have a mistake in here, back at -1. Let's recalculate that one, because I can tell right away that one's actually not right by comparing it to the other values. Oh, there we go. My mistake is my decimal's in the wrong place. So if you're ever working on stuff and you see a value that doesn't make sense, I would go back and check it. So here, I was working really quickly, so I didn't notice it. But when I went and I was trying to graph it, I noticed that value didn't make sense compared to what I already found. Go back, recalculate it then, okay? There's no shame in going back and fixing your work. If, as a teacher, I can make mistakes, as a student, that means you can also. You're going to be making mistakes. Just go back and fix them quickly. Now, when we get that small of values, we're no longer going to be able to accurately graph them, okay? So that's going to be it that I show for my graph, because those values, as they get closer and closer to 0, they're going to be more and more difficult to graph. So remember, it's just going to slide up there and approach the asymptote forever. And let's take a look at everything else now. So the y-intercept, when x is 0, the y-intercept is at 0.5, which again makes sense because we talked about that multiplier helping control the y-intercept. Domain. The domain is always going to be all real numbers. There's no restrictions on the x's we can use. The range. Well, let's talk about the range. We're comparing it to 0, But notice now my graph goes underneath my asymptote. Okay, the graph is dropping underneath it. So now my y's are going to be strictly less than 0. Remember, it can't actually be 0. It's going to be strictly less than 0. So what's changed from the parent function? Well, we already know the y-intercept. We talked about that last time, right, in the first example. And what about the range? Well, the range is now less than because of the y-axis reflection, or the x-axis reflection. Because it reflected underneath, now it's going downward instead of going up. Okay? So, now that takes care of stretches, compressions, and reflections. So now we're going to move into translations. Now remember, translations do not go in the table, okay? Those shifts do not go in the table. The table is strictly for the parent function with a stretch, compression, or reflection, and then we're going to move our graph around, okay? So, looking at our graph. So here, we want to look at just a parent function, okay? We're going to ignore that -4 with the x for now. We just want the parent function, okay? So, 2 to the second power is 4. 2 to the first power is 2. 2 to the 0 power is 1. 2 to the -1 is 0.5. 2 to the -2 is 0.25. So I'm just going to breeze through that because I've already shown you how to type those into the calculator. Okay, so that's not my huge concern right now. You should know how to do that by this point. Okay, typing it into the parent function, which is that right there. So I'm going to plot those points. So -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4. Okay, now, so I have those, but now, remember, whenever we have translation. So here, what that's telling me is move everything to the right 4. Okay, so remember, that's what you do with any shifting. Okay, we're going to shift everything over 4 to the right. So 1, 2, 3, 4. There's my new bottom point. 1, 2, 3, 4. 1, 2, 3, 4. So I just slide everything over 4 units. Okay, remember, when the shifting is with the x, that is horizontal. That's shifting to the right and to the left. Now what I want you to notice, my asymptote still hasn't changed, okay? Horizontal shifting, just shifting things to the right and the left, doesn't impact my asymptote. It's still sitting right at 0 where it was before. And now my graph looks like that. Again, it's going to approach asymptote forever, so that's why before you draw in your graph, I want you to place that asymptote, because otherwise it's going to be really, really difficult to see where it's approaching. Okay, draw the asymptote. Your graph is just going to be approaching it forever. Now, the y-intercept. In this case, the y-intercept is actually a little bit trickier, okay, because it's very difficult to see graphically. Our table we can't use because it doesn't incorporate the translation. So if you think about the asymptote is wherever x is 0. So if you think about the original function where x is 0, that's what it would be. Okay, so in this case, I'm going to go and I'm going to just plug it back in. 2, oh, 2 to the 0 minus 4. So our y-intercept is going to be sitting there. Okay? So again, just remembering what the y-intercept means. All it means is the y value where x is 0. Okay? Just re-emphasizing that idea. Domain. Well, hopefully you guys remember domain is always all real numbers. And range are y values, and you're always comparing it to the asymptote. Okay? And the asymptote is still at 0, and my graph is above that 0. So my graph is strictly greater than 0. Remember, strictly greater than because it can't actually be 0. It can't actually be at that asymptote. So what's changed from the parent function? Again, right now, mainly the y-intercept is the thing that's changing, okay? My asymptote, still not. Domain will never change. So still these things, we're seeing some movement in that y-intercept, okay? So, last thing, vertical translations. So here I've incorporated in a couple of other things in there too. Notice that I did incorporate a stretch in there as well, okay? Just so you get used to doing that. Now remember, we're going to graph the parent function. Now the parent function is just the parent function with its stretch, okay? Remember, any shifting, so that minus 7, or if anything was shifting the x, remember that we keep outside. We keep it for later, okay? So all I'm focusing on is this piece right here, that basic parent function with the stretch. So let's find some of those values now. And again, these you can just type right into the calculator. Again, using this piece right here, let's plug in a -2. So 8 times 1/2 to the -2. That's giving me a 32. That's going to be a huge, huge number. Okay, so that one we're not even going to be able to see. So let's move on to the next one. Let's see what happens when we plug in -1. We get 16. So that's still kind of big. We're still not actually going to be able to see that on our graph. Let's try 0. Now 0, you know, will turn anything into 1. So you're probably going to notice here all that's going to be left is that thing out front, the 8. 0, 8. Now let's plug in 1. Sorry, 8 times 1/2 to the 1. We get 4. Let's plug in a 2. We get 2. Now something you're probably noticing is notice because of this, every one you do is being cut in half. So probably you can even see the pattern. Let's say I go to the next one. It's just going to cut that in half. So notice patterns like that. You're going to see that. Hopefully you saw it earlier too, but definitely in this one. Notice because of that 1/2, every shift you make is being multiplied by a half. So you could actually keep going in the table yourself once you recognize that pattern that, oh, next time it's just being multiplied by a half again. You could probably do all of that yourself. All right, so let's go and plot those points, shall we? So again, a lot of them we're not going to be able to plot, like that -2, 32. That's way too big. The first one we're going to be able to plot is that one right there at 0, 8, then 1, 4, 2, 2, and then 3, 1. And again, if you follow that pattern, cutting it in half again, when you went up to 4, you'd be down to 1/2. So again, hopefully you're just seeing those patterns, okay? It's all about pattern recognition. So I've plotted everything that was in my table. Now let's take a look at this. What is that telling me to do? Well, hopefully you guys know that is a shift down 7. Okay, so you're taking every one of those and you're going to shift it down 7. So let's do that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, something you've probably noticed here, this is the first time our asymptote is going to shift. Notice with our function moving down 7. Notice our asymptote, that is also going to move down 7. So this is the first time that we've come across a situation, this vertical shift, that is actually the only thing that is going to move around your asymptote. Okay, that's the key because that is actually taking your whole function and moving it up or down, including the asymptote. So that is the only time you're going to see our asymptote shift. So again, my personal recommendation, put that asymptote in first, because now when you graph this, now you know where to trail your graph off to. Okay, if you don't have that asymptote there, I've seen some wacky things happen with my kids' graphs. So make sure you draw on that asymptote. And again, the only time it changes is with that vertical translation. All right, the y-intercept. So again, y-intercept is where x is 0, okay? Now, when you have to shift things around, remember you can't use your table to determine the y-intercept anymore. But this time the y-intercept actually landed nicely, where when you plug in 0 to this original function, it actually comes out as 1. Okay, and you can see that in the graph. Before, the reason I plugged it back in the calculator is because you couldn't see it graphically. This time you can. It turned out to be a nice number, so based on the graph, I can see that it's at 1. The domain is going to be all real numbers. My range, remember the range you compare to your asymptote. So now I know my asymptote is down at -7. So that's what I'm going to compare my y values to. My y values are greater than it. You can see they're above it. So my y's are all strictly greater than -7. Again, remember, strictly greater than because it will never actually be 7. It'll never actually touch that line. It'll just approach it forever. So what's changed? Well, obviously the y-intercept always changes, and this is where the asymptote moves up and down with the shift. Okay, this is the only time you're going to see the asymptote move, is when you have a vertical shift, a vertical translation. Otherwise, it stays put. And again, it is very important. It is always the first thing you put because you want to know where your graph is trailing off to so you can be as accurate as possible. All right, so that is going to be all for today. Now here, I've actually typed in some really good things to discuss. So, because I've typed those in for you, that's what I want you to answer in your summary. Okay, some of the key highlights of all these graphs, the things I want you to walk away from this video absolutely knowing about your graphs. So please make sure to fill out that summary and then come back with your notes filled out, ready to do your practice work.